Let's find the equation of a hyperbola. Find the set of points x comma y whose distance from c comma 0 and distance from negative c comma 0 subtract to 2a. So you'll notice that most of this is the same as for finding the equation of an ellipse. So please go and find the proof of the ellipse and make sure that you understand that one, because most of it is going to be copied and pasted here. So the only difference being we're subtracting 2. So I've copied over all the parts that are relevant from the ellipse. Here we have subtraction instead of addition, but you'll find that that subtraction doesn't actually end up being relevant, because when we get to this point where the subtraction sign is, we divide by negative on both sides, and then when we square it, we get the exact same thing as if we squared 2a squared minus x squared plus y squared plus c squared. If we switch these, we still get the same thing. This is the idea that squaring a negative gets rid of the negative, so we kind of lost the difference between the hyperbola and ellipse. But there is one big difference between a hyperbola and an ellipse. And in an ellipse, in the ellipse we said that c squared equals a squared minus b squared. But in a hyperbola, we say c squared equals a squared plus b squared. So that's going to be why things change from here. So what I'm going to do, in the ellipse equation, we substituted in c squared equals a squared minus b squared. Now we're going to substitute in a squared plus b squared. So negative a squared plus, this is going to be a squared plus b squared, x squared times a squared plus b squared minus a squared, and minus y squared. Now the a squareds here are going to cancel, the a squareds there are going to cancel, and we're left with b squared equals x squared times b squared over a squared minus y squared. And now, in order to get this to be 1, we divide by b squared on both sides. X squared over a squared minus y squared over dividing by b squared gives us b squared. So there's the proof of our equation of a hyperbola.